The Sporland division of Parker Hannifin Corporation is sponsoring this podcast. Sporland is the leading manufacturer of HVAC and R components. Using quality materials and craftsmanship, Sporland maintains a commitment to innovation, manufacturing excellence, service, and support for its customers since 1934. The company is known for its catch-all filter dryers, thermostatic expansion valves, solenoid valves, pressure regulating valves, suction filters, electric valves, controllers, supermarket monitoring solutions, chemicals, smart service tools, Zoom Lock Max, press to connect, and Zoom Lock Push to connect refrigerant fittings. If folks want to learn more, what do?
You can go to sporland.com.
I guess that's Jim and John for Sporland signing off.
We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of the day or night to check stock on your favorite brands, such as Copeland, Sporland, Carlisle Compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann Parts, and K2Therm. United Refrigeration, Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration, Inc. has all your solutions down cold.
I think it's evening. Good evening, everybody. Welcome to Advanced Refrigeration Podcast. You're here with the host, Brett Wetzel and Kevin Compass. Kevin looks like it's good, man. Kevin looks like he's dying already. It's only Tuesday. What the hell? Why are you dying already?
It's Tuesday. It was 50 yesterday, and now it's 28 today, and it was like 30-mile-an-hour winds all day. And yeah, it was on a roof for 8 hours straight, wiring up rooftop boards. Just getting the shit beat out of me by rooftop doors with no hold opens on it. So,
is this the same store that you were doing the Danfoss thing downstairs?
Yeah. Now we're upstairs with I don't even know why we're putting them in half the rooftops. Half the rooftops don't work. Opened up two of them today. There was no power there. There was no power wires in there.
Really?
Yeah. I'm like,
that sounds awfully fun.
Yeah, I don't know. It was not fun. Then Monday I worked on some, I don't even know what to call it. Some just hacked, cobbled together CO2 rack.
It was green cool, not green chill, by the way. Because once you sent me the picture.
Yeah, whatever. Swedish Dutch rack.
when I thought green chill, I was thinking like that. That's why I said Hill Phoenix all of a sudden, because I was like, oh, it's whenever they get it under the certification to make it green chill certified. So that's what I was thinking that it was, but it was not. It was some other company I've never heard of.
Yeah, they were from Sweden. It honestly has to be one of the first transcritical racks in the U.S.
What customer though? Or can you not say? Oh, okay. Well, because that looked like a pretty big rack for a Walgreens. Like, how big is this fucking Walgreens?
It's not like super big, but it's doing all the heating, all the cooling, all the refrigeration, which is pinched off. So it was doing a lot, but like the chiller load alone was probably 60 tons.
Wow.
It was a massively it's oversized, like without a doubt.
Okay.
Like the rack, but just you're talking the beginning of transcritical, probably.
You think?
Like no flash gas bypass valve, it's just a solenoid, no stepper, basic like control, like Schneider PLC. Looked like a cross between if you took an LMP rack and a early Carnot rack and slapped them together, it would kind of look like that. But like, then you made it even more impossible to work on. Like
And you said it was kind of butchered too. Like there was some what would you find for the oil solenoids?
So the high pressure oil solenoids, that this was a high pressure oil system, had a temp right coming out of it, kind of like a weird high pressure with a reservoir kind of setup, which I'll explain in a second. But like two of the high pressure oil solenoids on the high temp compressors, the air conditioning compressors, were definitely ASCO water solenoids that were rated at like 56 psi.
I don't know how they didn't blow out.
And I thought, yeah, maybe somebody just slapped the coils on there that they couldn't find and like started taking pictures of it like with the phone like underneath. And it's like, oh, that's an ASCO solenoid. That's not, it was thin brass, thin.
And you said, didn't you say it was like 100? It was 140 bar system. So like, if it's a high pressure system, you're seeing like what 1,400 pounds at the oil system, right?
Well, yeah, and then it's made to shut down and idle. So it should die and not blow the reliefs. But it's a little more complicated than that. Like the flash tank settings were like really high, like 900 pounds, and then like the whole like control scheme, like it was some Schneider Electric PLC. Like the whole control scheme was just like goofy and like didn't really work that well. The way what they were doing, like it was very archaic.
Mm-hmm.
Like you could have thrown an E2 in there and like done it like 50 times better, probably. It was just like they were doing all the high pressure calculations with the PLC, no 326, just iCAD drivers. Very, very like the PLC was a nice layout, but like half the shit's in like different languages. So then you like look it up.
You probably can't even get into the programming on that PLC unless you had a special cable program.
Well, no, like you can get into the HMI display, but like the problem is somebody changed the password and nobody knows what it changed to.
Did you try Walgreens?
Yeah, no, it's there's just a lot going on here. So like this rack simultaneously heats and cools the building and does the refrigeration. So it's a heat pump basically. Mm-hmm. At the core of this thing, it's a heat pump. So there's like 4 GOLs that are like, I think they're 400 feet in the ground, it said. And yeah.
So like what do you do at that point? So like, I mean, like me, I'm looking for the refrigeration schedule. I'm looking for any kind of documentation that's going to tell me something, some semblance of what the fuck it was supposed to be running at, right?
So there was a piping schematic on the wall, but like I really didn't like follow that too much. Like I always start at the same place with like stuff like that. I started the oil separator.
No, but I meant like as far as like it, because you said the flash tank was like 900 pounds, but like you also said that you don't really know why it's supposed to be there. So like that's what I'm saying. So like if you look at most refrigeration schedules, it'll tell you about what your saturated flash tank pressure should be and all that other stuff as far as your suction, you know how the discharge is being controlled and all that other stuff.
So it was a floating set point. So it went from like 535 to 9 something, depending on what mode the rack was in, whether it was in heat pump mode or if it was in just normal refrigeration mode.
Are they using the flash tank pressure in order to heat the building, or where are they getting the heat?
No, so what they're doing is they're using the parallel compression air conditioning compressors as parallel compression compressors, and they're actually using those to drive a chiller, which is pulling BTUs out of the geo loop.
Uh-huh.
There's a heat exchanger basically built into there's a water like heat exchanger built in next to the rack that's taking it's either chilled water going through there and going out to the air handlers, or it switches over and there's a geo loop that goes into this heat exchanger that allows you to pull BTUs out of the geo loop. And then at the same time, it's also rejecting heat back into the geo loop to keep the rack back loaded up and running if the hot water in the building gets to temp.
Jesus. And you only were there for one day, right?
I was there for like 6 hours. We got the hot water up to like 157 degrees is what I got out of it. All the refrigeration's cut off. Like it hasn't worked in months. Like all the lines are leaking. Like it was all pinched off the cooler and freezer. So those weren't running. The whole way the rack is like piped and like set up is just like completely wrong. Like it's just no high pressure switches on the TC compressors. Like, so they're just blowing the reliefs constantly. We pulled the high pressure valve apart. And it was all covered in like sugar dust from like them TIG welding when not flowing nitrogen through. And we got that. I think that was the majority of it. Like, I think the ICAD valve is messing up.
Yeah.
Because it's so gummed up with shit. But the whole thing is just like a hobbled up mess. Like we were looking through like books and like trying to find everything. And it's just very poorly laid out piece of equipment. Like
you would have had to spend a day just calling all the engineers that originally did all the drawings so you could see what the fuck and how it was supposed to be running originally.
We're in Sweden. International calls. And it's like 3 a.m. there when it's like they're like a huge time difference.
Send an email.
Yeah, at that point, like it's just I was there for a favor and we got it back running, and yeah, it's probably
you don't want to do any more favors, huh?
Not with that. Like it's stuff like that. It's like then I'm married to it.
Well, that's the thing. Like that's why I don't do any side work at all, because how many times I'm like, yeah, I'll just go over there and charge it up for the time being just to get you through. And then any other fucking hiccup from there on out, it ends up being mine. And I'm just like, no, can't, won't, don't want to do it.
You know? This wasn't side work. This is through like my company, but
no, I get it.
Yeah,
this is well, that's all is like doing favors for people. You know what I mean?
Yeah, I try to, but like right now, like I'm so backed up with work. I'm ready just to bash my head against a wall.
Sweet. No, I'm in California this week doing some training again. I think this is the last time I'm actually doing training for the year, though, until October, November, and December. So
it's the beginning of the year.
Well, I know, but I just meant for our training season, because our training season goes from October, November, December, January, February, March. So I'm not training anymore. I got a family vacation coming up in March, and then I'm supposed to go somewhere. I'm going to be back in California, back on the 4th or something like that. I don't know. I got to spend a lot of time down in Houston. I got a shit ton of work to do, and things just keep happening. It's just not fun. But what are we talking about tonight? I heard something. You said something about thermal imaging.
So we're going to talk about thermal imaging 101. Sorry.
Turn off your fucking phone. I thought it was Greg texting you.
No, it's my
By the way, you're not allowed to talk to him anymore because he fucking gives me shit all the time now.
Oh, he's getting so great.
He gives me so bad of an attitude. So like, I guess ever since he got his polo, he now has become very arrogant. So, and which kind of makes sense because he's hitting that 5-year mark. Although when we get off here, I got to tell you a funny story how they ended up at a wrong side of the neighborhood out here in California. Unless you want to hear it now.
No, we'll do that later.
You want to hear it now?
No.
Oh, you're so lame.
So, all right, we're going to talk about thermal imaging 101. So, as you guys,
Got a better story than
obviously,
thermal imaging.
yeah, I fucking hate you some days. We're going to talk about thermal imaging. Everybody's seen a thermal imager for the most part. Like they're starting to become more and more commonplace. You're starting to see them in supply houses. You're starting to see them. Techs have them. So, what is a thermal imager? So, a thermal imager is a device that measures the temperature infrared rays that are coming back off of a piece of material. Did I freeze? I can't hear you.
Oh, it's because I'm muted. I was trying to be polite while you were talking.
No, I thought I froze.
No, you didn't freeze.
So, all right, a thermal imager is measuring the infrared rays coming back off of a piece of material. So, this is where we're going to talk about a couple keywords here: thermal emissivity. So, thermal emissivity is how much the rays come off of something. So, the best way to look at this is to look and see how much electricity something can conduct. Like copper is, or aluminum is very immiscible. Wood is not very immiscible. Like wood is very dense. It's not gonna show up very well. But like aluminum, copper, metal, plastic, stuff like that is more immiscible. So it's going to show up more on a thermal imager. Now, thermal imaging, what could you use it for? For us in the HVAC and refrigeration trade, a ton. Checking compressors, checking door gaskets, checking door frame heaters, checking heaters on coils, checking for air gaps and air leaks. So we're going to go over each one and break it down. So compressors like got to be one of my favorite. So you're looking at valve plates on like Carlisle's or Bitzers where they have split heads. So if you're looking at them, you could easily tell which head is blown or has a bad gasket or a bad. Go ahead, Brett.
No, I just want to remind you, since you're talking about it, because guys are going to be like, well, what is he talking about? Do me a favor and send me some pictures so I can throw that shit up there on the Facebook group.
Yeah, I will. So if you have a bad gasket or a bad valve plate, you could instantly see it because you have one head that's half red, half blue. You know, it's got suction gas going on one side and discharge gas going out the other. And you got one head that's glowing red, basically, or orange, depending on how you have your emissivity set up inside your thermal imager. It'll be glowing a different color because it's way hotter. So right then and there, you could go, okay, boom, I know I have to pull that head. The other head's fine. I could just pull this one. So right then and there, you have a leg up on another technician. Instead of just performing an efficiency test, you're performing an efficiency test and knowing which head you have to pull. So it makes that easier. Finding issues with like compressor, like with bleed by. If you're like blowing discharge gas into the crankcase more, you could see, okay, you're looking, this crankcase is glowing red, or this crankcase is warmer than the other crankcases. Why is it warmer than the other crankcases? So instead of like going around with an infrared thermometer, like all the old guys do, you know, the little thermal gun that's really not really that accurate, you can go around this imager and see the whole picture for compressors and stuff like that. Loose wiring is a huge one. Finding breakers before they cause issues with the loose connections on breakers that are, especially like large breakers, like rack breakers. Like when I'm doing PMs, I'm checking the rack mains to make sure there's no loose connections without me having to physically get out tools and look at them. I'm able to look at
Wait a minute. I'm confused. When do you do PMs?
I haven't done PMs in a little while, but
I'm just breaking your balls. Sorry.
it's the last time you had a tool bag.
I carried the tool bag today, by the way.
But yeah, so going through PMs and checking like the rack lugs, That way you could see without having to get out and tighten lugs on the rack, which you don't want to do that, especially if it's in the switch gear. You could just check the switch gear and see if you have a spot that's warmer. It'll show up plain as day. If there is a loose wire, you'll have one that's like 5-10 degrees higher than the other, and that's something you got to investigate and maybe have an electrician come tighten the lugs down, or shut the gear down and tighten the lugs down. Or if you're checking contactors and stuff, you could look through and, okay, there's number 3 contactor's got a hot spot on the L2 on the points. You can see this is more of like a predictive maintenance in a sense. You could tell something's going to fail before it does, because you're able to look at the thermal imager and see the hot spots in there, and you're able to change that part out or tighten that connection or fix that wire that's burning up before another tech is going to be able to see that. You're able to predict that failure.
Also with compressors, you can see, especially with the pesky Super Plus racks, right, that have the external line that goes from oil pot to oil pot. Basically, you can see if, what oil is going out from that one compressor, to see which one is basically pressurizing the rest of the loop and causing oil failures on the rest of the rack. So that comes in quite handy.
The other cool thing with that, if you got oil pots overfeeding, which you could usually test this with your hand, but this is a really cool like training thing for like apprentices, is you show them with the imager, you show them the oil lines, and you could see which pots are overfilling, which ones are constantly feeding that oil, especially on the Super Plus racks. Because I don't know, for some god awful reason, those things had like the worst oil issues ever.
I think it's a misunderstanding on how that system works, like why you actually have that secondary line that comes off the oil pot, which is essentially the crankcase, and not knowing like when and where those lines are, what's the reason for them, right? And a lot of people don't understand
them all off.
What?
Valve them all off.
No, don't fucking listen to him.
I valve them all off, and the on-call guy will thank you every day.
I get what you're saying, but like a lot of times, like especially with Carlisle compressors, if you have that one compressor that just keeps running full bore, and that one compressor keeps filling up with an obscene amount of oil, and you have that valved off, as you say, now all of a sudden you're losing compressors because that fucker's filling up with too much oil.
I've never seen it help. I've never seen it stop a compressor from overfilling.
Maybe you don't understand how it works.
I know
you need to watch more videos.
Yeah, I know how it works. I just never seen it actually function in the way it's supposed to. As soon as you change that separator out to one that's properly sized, the oil issues usually go away.
That's 100% positive.
Yeah, those first gen Temporites or those first gen centrifugals were like way oversized.
100%.
So back to the thermal imaging. So on the compressors, obviously we went over that, and then the oil. Being able to see the oil system with that is a huge deal. The other thing is, it depends on how much heat's in the system when you're doing this. You could also see receiver levels. Generally, you'll have to stop the system to see it, let it cool down to see a different level in there. But checking on self-contains, you could check receiver levels. If they have a receiver or like single units, you could check receiver levels on there. And the receiver heater is really easy. If you're doing PMs, just breeze by. Okay, that receiver heater is working. Crankcase heater, same thing. You could see if those are working like instantly.
Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westermeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/floats. /float. Let's get on with the episode. You can shoot a hot gas bypass valve and see if it's feeding, or the receiver repressurization valve and see if that's feeding when it's really not supposed to.
So that is pretty cool. Like let's see if I can find a picture of it. I have like a picture of an undercharged headmaster, and you could see it. It's cool coming in, but the whole bottom of the valve is red as it's injecting hot gas into the top of the receiver, and the whole top of the receiver is red.
Sweet.
Yeah, you could see that whole operation of the headmaster. So in a sense, you could almost use it to help troubleshoot.
Absolutely. And then back to the oil, you can also use that thermal imaging camera. We talked about in a lot of the oil podcasts that we've done. If you haven't listened to them, I recommend going back because there's so much good information in there. But Kevin had stated at one point that he likes putting a Cooper on the bottom there of the float and seeing it actually feed. And it's really cool to take a thermal imaging camera and doing that same thing, but seeing like the spurts of when it fills up and then shoots out the oil, and vice versa. You know what I mean? So you can actually see if that's feeding properly the way it should.
Yeah. The only thing is, like with copper, is it's kind of difficult the way that copper shines back. Like you need to have a higher quality thermal imager to look at copper.
Yeah. Well, the other thing is that there's also settings in a lot. Which one do you have? You have the Flare or what?
I have an E6 that's hacked, an E8.
Well, I believe in my cheapy one, I only have the $300 one, but like in mine, like I can change. It also has to deal with how shiny something is. So like sometimes the shinier it is, you have to change that one setting to make it show more prevalent on things that are shinier. I forget because, as Kevin stated numerous times, that I haven't been out in the field in once in a while.
Yeah, so like the shinier it is, the more it affects it. Like, and then same thing with glass. So a thermal imager will not see through glass. So glass disrupts the thermal rays. So it can't see through the glass. It stops the thermal rays from hitting it. So the thermal imaging, you're not going to see through walls with it. You're not going to see through concrete for the most part. You could see like radiant tubing in concrete, but you're not going to see like straight through. It's going to see the first surface that it is, and it's going to read that surface temperature. So you're not going to see through walls and stuff, but you are able to see radiant floor leaks. We use it to find a radiant floor leak in my buddy's barn. Like we were able to find where the radiant floor, they had in floor heat in the concrete. We were able to see where the boiler was losing water through the floor. I mean, go ahead, Brett. You're muted.
Oh, sorry. You had to dig that up. You had to dig the concrete up to
fix
that.
They had to cut like a square of it out and 1 by 1 square and just fix the PEX tubing where it was leaking instead of cutting out like a massive chunk of concrete.
How does that happen though? Like that's something I never understood. Like if you have PEX tubing and it's in fucking concrete, how does it end up getting holes in it?
It was just like a tube failure. Like it happens quite a bit. Really? I mean, it was just it wasn't on a joint or anything. It was just a tube failure. Somebody probably stepped on it when they were putting it in, or walked on it, or was rubbed against rebar. But like, yeah, we were able to find that, and you were able to fix it without ripping up a huge section of concrete. So that's where a thermal imager comes in, like super handy too. So
I guess hell, if you're a plumber, it would be kind of helpful too to try to see where you got shit leaking out in the yard, right?
Yeah, like water lines. Like I found my septic with it.
Oh, well, I forgot I did this. So the first week in my house, my daughter, my middle one, she decided to throw something down the toilet. I went to go flush the toilet and it didn't work. And I was like, I was just in here 2 hours ago. Like, wait, what the fuck happened? I was like, who was in the bathroom? She's like, I was. I'm like, did you happen to put something in the toilet? She's like, it accidentally fell. And this is a ball that like almost like a pickleball, right? Like almost the size of a small baseball. And I was really pissed because I kept trying to clear whatever was out in there out, and I just couldn't. And I just wanted to make sure I wasn't losing it because I didn't know if this said ball went into the piping and backed everything up, or it was stuck in the gooseneck of the toilet. So I ended up pouring really, really hot water down there and then hit it with a thermal imaging camera, and you could see the ball stuck in the gooseneck of the fucking toilet. So the first week I'm in the new house, I'm on the yard with the toilet ripped out on the front yard, trying to get this fucking ball out. But that was a good, useful time that I used my thermal imaging camera.
Yeah, it does work for stuff like that. I was able to find my septic field when we moved in this house, like find the septic lid, just run the bathtub, and you could see it plain as day. You could see the line going out, and you could see the heat coming out of the septic.
What are
So,
some other uses that
so
you've seen the
my
thermal imaging used for?
one of my favorites is door frame heaters. So you're doing a PM and you're going through stuff and you're troubleshooting door frame heaters, or you're looking at door frame heaters. You could literally walk the whole aisle instead of going through each one with a contact thermometer or a contact pen and making sure they're working and making sure the doors are warm. You could literally go through the whole aisle, scan it by walking or finding bad doors, like doors where the argon seal has been lost or doors with the heaters out before it's like sweating. So say it's like right now in Chicago, like you could have doors with bad heaters in them and they're not going to show up. There's no humidity right now. It's doors are like nice tempered, you know, nice and dry. So those doors are going to show up. But like you're doing the PM now, okay, you can find 5, 6 bad doors just by going through and with the thermal imager. Okay, red, blue. Okay, that one's blue. It's not heating. And you go over to it, make sure it's got power, and the next you're writing up a door. So it's like easy PM stuff. You're catching stuff on PMs that other guys are going to catch, or vice versa. You're working on frame heaters. So say you're working on an Anthony frame, they may have 5 to 7 heaters in it. Okay, well, you either got to rip all the mullions off to figure out what's going on, to figure out what heater's doing what or what's going on. Now with this thermal imager, you could shoot that frame and say, okay, door 2 and 3, those heaters aren't working and the inner heaters aren't working. Okay, all the other heaters seem like they're good. So I'll just pull door 2 and 3 and check the heaters for those instead of pulling off the mullions and covers. Because I don't know about you, anytime I pull those black covers off, I spend more time cussing and hating my life trying to get those things back clipped on than anything. Or they always like you're going to set them down, they bend like slightly, and then it won't go back together, and you just hate everything.
100%, 100%. You're talking about the Husman ones, right?
No, the Anthony ones with the shorter frame covers.
Oh no, I don't know that. Nah, I don't know.
The Husman ones are a pain in the dick because they you gotta peel out the screwdriver and it's all fiberglass, and you peel just a little bit too hard, you're gonna crack the fiberglass.
100. So speaking about plumbing, you can also use it for finding a restriction in your case lineup too, right? Instead of having to try to cut and figure out where you have a potential blockage in your drain, you could also use the thermal imaging for that as well.
So plugs, on occasion, this comes out of the van for plugs, like in lines,
Plugs
like liquid plugs or like suction plugs. Obviously, I do startups primarily, and it happens from time to time. It's gotten worse here lately. We've had a lot of double plugged pipe again. It seemed like it happened like 5 or 6 years ago, and it came back again.
Refrigeration piping?
Yeah.
That sucks.
So double plug pipe, and if you don't get experienced pipe fitters and you get some newer guys or apprentices or green guys piping stuff, and they don't look down the pipe, and there's a double plug and another 3 foot down, getting a pipe plug in there. I've used it. It's kind of a bitch if there's insulation, but if you're using it, you're shooting the copper, you could see, okay, it's 80, 80, 10. Oh shit. That's where it's metering at.
Wait, you're seeing that on the liquid side. I think you see that, but even on the suction side, you're going to see that type.
Suction side, you can usually see it too, because usually the other side of the pipe is usually more room temp.
Oh, it's going to be warmer, right? So you'll have a nice cool temperature on the inlet side, and on the outlet side, it's going to eat shit and get warmer then, right?
Usually it's the opposite. Usually the suction side, the evaporator side where it's plugged, usually is higher. So it's backed up with liquid and vapor refrigerant because it's not really doing anything. But the other side where that plug is, either refrigeration effects happening, you're lowering that pressure. So they're checking drain heaters on heat tape, making sure heat tape's working. So big box warehouses like Costco's and other stuff, it's a pain to get in there. Like during startup, a lot of times to get the drain heaters checked, or they start putting stuff in there. But every single job, we run the same problem. The electricians are moving stuff around, and they end up turning off the heat tape, and then they end up freezing up the pans. So it's like every job. So like now, like when I'm doing startup, I check it once a day, make sure that before I leave, those heaters are on.
I'm surprised you haven't made it standard practice with some of these bigger stores, because you know how much money that it costs you, right? You know how much it's going to cost you to have to drop all the pans, get all the fucking ice up, clean that up. We need to make a push to make it standard practice that you have a DI on the heat tape. So if it's not pulling the proper amount of amperage, it throws out an alarm, say, hey, this is fucked up. You need to go take a look at this before it becomes an issue.
So if I'm doing change outs, like specifically like MT change outs at that store, and I have to pull a wire over there, like towards that way, I end up adding a temp sensor at each end of the box for the heat tape. So I use a temp sensor and I just strap it to the line by the heat tape and then set an alarm up. If it gets to 32 degrees, then for like an hour, then it's going to alarm out.
Gotcha.
For the heat tape failure. I would much rather be there for a heat tape failure alarm and know the heat tape went out and fix that than anything. And then I really wish they would stop putting damn GFCIs on heat tape.
But they have to, though, because of the water, right?
I don't know. Like they fail all the time. They nuisance trip so much. Like I can't even tell you how many Walmarts I've had nuisance trip heat tape, and then like 60 foot of drain line is just split everywhere. Like I refuse to start fixing like drain line anymore. Like I'll patch it up every once in a while, but it's all getting replaced.
Yeah, we need to make that starting standard practice. So any of you customers are listening, start putting DIs on the heat tape, because it'll end up saving you a boatload of money. Rather have a call someone to fix the heat tape right away than let it ice up, and you have a big pile of ice on the floor. What were we gonna say?
I think temp sensors are slightly more responsive with it.
Well,
okay. But like, what is an average cost to change the drain in the freezer, depending on like how big it is? Like, it's got to be every bit of like a $4,000 to $5,000 bill, depending on what it is.
I guess it depends on how big the copper is and how long of a run you're talking, right? Typically, it only ruptures at one spot, right?
No, I always usually get it in like 6 spots.
Lucky like you.
Well, you fix one spot, then it's like it starts going, and all of a sudden it's leaking over there, and you're like, just then you're fixing it again. Like, but me personally, I hate it when guys run heat tape just along the bottom of the pipe. I like it wrapped.
No, I agree with you.
Yeah,
I agree with you. I don't understand the method of just running it underneath,
because it's expensive.
With the heat tape?
Fuck yeah, heat tape is expensive.
Oh, I don't even care. It's getting wrapped all the way around.
See, the problem is like on service, that's fine. Like you could just wrap it all around because you're billing the customer, and it's gonna be better. But like on construction, I get it. When you're heat taping that many drains, that's big money.
No, I get it, but you're asking for service issues in the future.
Correct.
You're asking for it.
That's why it needs to be a spec.
100%. I agree.
Yeah, and then like Armaflex is outrageously expensive too.
Yeah, it's almost more than some of the pipe.
Yeah, it's like 2-inch Armo is more than pipe.
God damn. Oh, I mean, hey, listen, we're squirreling and getting off topic. Thermal imaging.
Yeah.
All right. Sorry, I'm going to be the voice of reason this time.
So door gaskets, obviously you can find door gaskets with it. As you're checking through there, you're going to see the doors red, and you're going to see all this blue, blackish tint on the outside the edges of the door gaskets, outside edges of the door. That's where the air's leaking out. You have cold air leaking out. Now, vice versa, if you're inside of a freezer or a box and you're scanning it and you see it glowing orange red, you could see like air penetration leaks. So boxes leaking air where they haven't sealed the silicone in there real good or foamed, line set penetrations, stuff where you're getting air into these coils, or like you're checking inside the coil electrical penetrations and you're getting air in through there, like stuff where you're having all frost and stuff all over the ceiling. I don't know how many times I've walked in there with a thermal imager and it's like I'm looking over the electric or everything else, and oh shit, there's a 3/4 inch whip here that bringing power into the coil that they didn't seal up real good, and air's leaking down it and causing moisture to get in the freezer and causing ice droplets on the tops of the box during defrost, or like penetration leaks or seal leaks, or you get the actual seams in the box. You can see when they're shot and there's ice in between them, and you're starting to get air leaks there. But it's looking for air leaks and penetration leaks is, you could show proof. Now you tell a customer, hey, look, you have all these air leaks in your box is shot. They're just going to, you send them some pictures, you use a couple split seams, and there's like, yeah, whatever, every box looks like that. Well, you take side by side pictures, like my imager takes dual pictures. It takes a normal picture and then it takes an infrared picture. So you show side by side pictures. Okay, here's a split here. Here is the temperature difference of the air entering here. Like, this is plain and simple. You could see like giant red line. And then my favorite thing to use it for is case troubleshooting. So meaning like multi-decks with product temp issues. So you could scan the whole multi-deck. You could find a fan out. You could be scanning 60 foot a case and you could see one fan out. You see that one section, especially Hussmann cases, you see that one section's running warmer, or, it's slightly warmer than the other sections. It'll lead you right to it. You'll see blue all the way across, and all of a sudden you'll see like an orangish spot where it's slightly warmer, and you can go over there and you can check your airflow. Oh, got a fan motor out here. It's a lot easier to check for case issues, especially in PMs, or if you have a customer that decides they know better than the manufacturer, they're going to put their own shelves in here, and they're doing pushers or they're doing pegs, and they don't believe you about the shelf on the bottom, which is, for the most part, there's published literature about it now. But if they don't believe you about the shelf on the bottom, or needing that airflow pocket or that simulated shelf there for the airflow, you could show them plain as day. You're shooting it with a thermal imager, and all that product on the front will be like bright red, where the pegboard is or the pushers are. It'll be glowing red or orange, where everything else is blue. That's where that airflow is disturbed. So, or like seeing stuff when it's overstocked over the product line, don't believe you. You can look through there. Like we were doing a bunch of fast alert commissioning for Kroger like 2 years ago, and that thermal imager made that job so much easier, because those fast alerts, probably 80% of what you're doing is fixing airflow issues in cases and retraining the store how to use their cases, because now they're putting these temp sensors in the warmest spots of the cases, and they're all return air basically. So it is basically testing these cases to the limit. And you would not believe how many stores we found fan blades that were wrong, airflow issues, but the thermal imager was like a key thing in there. It made our job so much easier, because we're able to go through these cases and just see right away, okay, boom, this case has, it's going to fail the fast alert commissioning no matter what, because section's warm right here. We're not getting airflow in this, or we have air blowing into the case, disturbing the airflow. We're able to see like, okay, this vent is blowing into the case, and it's causing the front product to run warm and the return to run warm. So then we're able to address that. And then, okay, we adjust the diffuser a little bit, and now we have the case is back blue. It's back not high temping in that one section. But that thermal imager makes that troubleshooting side of it a lot easier.
So I'd like to see some of the pictures, because my thermal imaging camera isn't nearly as cool as yours. Like, I don't think I don't know which one I have, but it doesn't show. I don't think it's going to show the resolution that you actually have on yours.
Yeah, so like that's a big thing we could talk about real quick. So resolution in cameras. So the higher the resolution, obviously, the better the thermal image is going to be. The higher the resolution, the higher the price tag. Now, I bought this thing like 5 years ago, so it was super expensive. Now they've come down like a ton. Like you can get the one you got. I think it's a Flare like TGI 65 or something.
I'll take your word for it, probably.
Is it like the handheld one, or is it the one that looks like a phone? So it's a handheld one. Like United has them. A lot of the supply houses around here have them. They sell them. It's like $300. It may even be cheaper now.
Yeah, I think that was 2 years ago when I bought mine.
It's a great tool. Now it's a great like beginner tool. Like if you're going to spend $300 on something, if you're going to spend $150 on a infrared thermometer, save your money and get that. It's 1,000 times better than an infrared thermometer. Like a little IR gun, like those are useless.
Yeah, so I think it's no, it's not the K65. Never mind. That's $8,000. I don't know which one I have.
The TGI 165.
Yeah, that's it. That's the cheapy one. And what do you have? The K65?
Mine's a E6.
E6.
So mine was like $4,000 when I bought it.
Oh my God, Cotter. E6. Yeah, $4,000. You say?
Yeah, it's probably way less now.
It's only $2,300.
Yeah, obviously technology, everything gets better and faster. So here's what I would recommend for you guys. You guys going to spend the money on something like this? You could buy a Flare E4, okay, for $1,000. You can get them on eBay for like $850. You could hack them for for nothing and make it an E8. So the E series, the only thing different in the E series is the software. The hardware for the resolution in the camera is the same sensor. So the only difference is they unlock the hardware in it or the software in it. So an E8 is like a super sensitive like camera. It's really has high resolution in it. An E4 is lower resolution, but just by hacking it, you can Google it. There's like so many Reddit threads on this. It's honestly not that hard.
Yeah, I'm gonna have to. Can I do it with my cheapy one?
No, like it has to be an E series. But like Fluke makes these, Testo makes these, Flare makes them. Me personally, I like Flare. Flare is like the top dog in the thermal game. They're the ones that make all the military scopes and everything else. Flare thermal imagers are great. But if you can't spend $1,000 on thermal imager, the one that Brett has is perfectly fine. It's not a thermal imager per se, but it's a thermal camera.
Yeah, so I misunderstood when I bought what I was getting.
Yes, it's not a full-on thermal imager, but I mean it's good enough for you to use for like troubleshooting and stuff. But like seeing all the case issues like I have, it's tougher. They also do make I think it's Seek makes one that plugs into like a iPhone or Android that you can have on the bottom. Obviously, that you're only going to get so much resolution with that, but you could use it to troubleshoot like basic things. Then you're going to walk in your house with it, and you're going to hate yourself because you're going to see every little air leak in your house and every little problem in your house. And then you're going to spend the next 3 months trying to seal air leaks in doors and windows. And I still have not fixed all the air leaks in my house.
Yeah. So I'm looking right now. The E4 is only good down to -2 degrees Fahrenheit, but goes all the way up to 482.
Yeah. You can buy those things for $900 to $1,000 on eBay.
But it doesn't do the lower temperature. If you want the one that you want, if the one that you have, I'm trying to see how low. Oh, okay, so this one, no, it's same thing. Temperature ranges only go down to -4 degrees. So niche geet for checking anything under -4.
Yeah, it still works in the freezer. I use mine all the time in the freezer.
No, but I'm saying just show an accurate temperature. That's all I'm saying.
It's fairly accurate, but I mean, how often are you checking inside of a free? You're using it to see air leaks. You're not going to be measuring suction line temperature with it.
Well, that's what I was thinking. I can start doing that.
Yeah, that's not going to work very well. You know what? Something cool we actually use this for. Anthony was having problems with the newer frames at the Aldi's. They weren't sealing the whips right per se, and we were getting ice behind the top mullion covers and all the raceways, but all the mullions would amp out. We were able to see the ice chunks behind the raceway covers before we pulled them off. You could see the middle raceway covers and all the cases were like that. We ended up pulling one of them, and I had to pull all the raceway covers to take pictures of the manufacturer to come fix it. I was able to pull one raceway cover and then take the thermal imager and duplicate it over and over and over again. It just makes your life easier. It's not a tool you absolutely need, but it makes your life a lot easier. When you get 16 hours to do a PM and in 8 hours you do the work in 16, and you have more time to spend doing other stuff like cleaning the rack room or being more thorough and not having to rush through a PM, because like a lot of BS stuff, like finding fan motors and finding door frame heaters out, that busy work to keep guys working, like you flew through that because you're able to see it all with your bare eyes instead of go to each door with a non-contact thermometer and see if, or a non-contact volt stick to see if it actually has an argon charge in it still.
Gotcha.
So, all right, guys, that's it for thermal imaging. Thanks for listening.
Later, guys.